Today we are going to start our topic Haloalkanes and Haloarenes. So the name of the chapter is Haloalkanes and Haloarenes. Have you heard about some of the chemicals such as chlorantraniliprole, chloroquine, or the thyroxine? All these chemicals are basically under the categories of the Haloalkanes and the Haloarenes. So the chlorantraniliprole, thyroxine, chloroquine are such type of drugs or chemicals which are included in this chapter, the heavy and minerals. First of all, let me here is a chlorine law. So chlorine is basically an antibiotic which is used to treat the thyroid fever. Antibiotic used on your thyroid fever is the chlorine. As the name suggests, the molecule is same. There is one chemical which is fluor. Think what fluor is basically representing the chlorine. So it is giving a chlorine within it. Similarly, if I am saying the thyroxine, so thyroxine is basically an hormone which is produced by the thyroid glands. The deficiency of thyroxine causes a disease called white. Thyroxine is basically an iodine containing hormone. So the thyroxine will be having the iodine as the halogen atom present in it. Now we are dealing about one more chemical which is chloroquine. Chloroquine is basically a drug which is used to treat or cure the malaria fever. So here also a one word which comes into play is chlor, which refers to chlorine. So these are certain chemicals in which you will find some halogen atom present in them. For example, the phenobarbital, which is an antibiotic. The thyroid fever is having chlorine as a halogen atom, while minoxidil is having a iodine atom, and chloroquine is having a chlorine atom. All these are considered under the section of haloalkanes and haloarenes. So now we are coming to the topic: what is a haloalkane? So, as the name suggests, halo means what? Halo means the halogens. The halogens present in a compound are considered as haloalkane, but this is not the complete definition. If we are talking about a haloalkane, if I am coming to its precise definition, so what does a haloalkane mean? Do anyone will tell what does a haloalkane mean? If we come to very precise and very simple definition, what do you think it means? That a halogen is attached to an element is halogen. But this is not the complete definition and not the accurate one. So haloalkanes are what? These are the compounds in which the halogen atom is bonded to sp3 hybridized carbon atom of alkyl. So the term haloalkane suggests that these are the compounds in which the halogen atom is attached to a sp3 hybridized carbon of an alkyl group. For example, what is a sp3 hybridized carbon? Just see here, I am taking it as an alkene. This is a compound in front of you which is a carbon compound and it is called ethane. As the carbon numbers are having a single bond between them, so it is also categorized under the case of alkene. And if I remove one of the hydrogen, if I remove one of the hydrogen by a hydrogen, which may be a fluorine, chlorine, bromine, or iodine, now it converts to a haloalkane. So what I have done here, I just have replaced one of the hydrogen of alkene by halogen, resulting in formation of a halogen. Point number one. Another point is the hydrogen is attached with this carbon, and the hybridization of this carbon must be sp3 in order to make it as a haloalkane. So haloalkane are having a hydrogen atom attached to an sp3 hybridized carbon. This is the most precise derivation according to the ACO. Now we are coming on to the next section of haloarenes. So here are one word concept common, which is halo, which refers to elements. And arene means benzene. So if a halogen atom is attached to a benzene ring, then it is considered under the haloarenes. But this is an incomplete definition. Now we are coming on to the complete definition of haloarenes as well. So the correct definition of haloarene is, I'm writing down here about the definition of haloarene. So haloarenes are what? These are the compounds in which halogen atom is attached to sp2 hybridized carbon atom of aryl group. Yes. So according to this definition, what is a haloarene? So the main thing which you have to note here is these are the compounds in which the halogen atom is attached to an sp2 hybridized carbon of an aryl group. What do this aryl mean? This means a benzene. So if I am saying this is a benzene ring in front of you, and in this benzene ring, each carbon is sp2 hybridized. So, to this sp2 hybridized carbon, when one of the hydrogen present with it is replaced by a halogen group, when one of the hydrogen atom attached to a sp2 hybridized carbon is replaced by a halogen group, now this is considered as a haloarene. So The carbon here is sp2 hybridized, and to this sp2 hybridized carbon, a halogen atom is attached, and this carbon is also a part of arene or a benzene ring. So this is the correct definition of haloalkane. If I'm dealing about both the sections of haloalkane and haloarene, the only difference which I see here is in case of haloalkane, the halogen atom is attached to a sp3 hybridized carbon atom of an alkyl group, while in case of haloarene, the halogen atom here is attached to an sp2 hybridized carbon atom of an aryl group or a benzene ring. This is the correct definition of haloalkanes and haloarenes. So, what would be its name? Its name will be a haloalkane, and more precisely saying, a halogen atom is attached with two carbon chain. So, it can be also considered as haloethane. And if the fluorine atom is present in place of halogen, so it will be fluoroethane. So if halogen is fluorine here, so the name of the compound will be fluoroethane. If halogen atom here is a chlorine, then the name will be chloroethane. And similarly, students tell me if there is a bromine present in place of halogen, or I must say if halogen is a bromine, then the name will be a bromoethane. And if the halogen is iodine here, then the name will be iodoethane. Similarly, this is a benzene ring, where one of the hydrogen is being replaced by fluorine. So the name will be fluorobenzene. What will it be?
Fluorobenzene.
Benzene. If the halogen, if the halogen is replaced by, or if the halogen is chlorine here, then the name will be chlorobenzene. So the name of first condition is fluorobenzene, and if the halogen here is chlorine, then the name will be chlorobenzene. Students, similarly tell me what will be the name if the halogen here is bromine, so then it will be bromobenzene, and so on. For the next case, when the halogen atom here is iodine, so the name will be iodobenzene.
Hmm.
After the case of haloalkanes and haloarenes, now we are coming on to the next section. The next section tells us about the different type of haloalkanes and haloarenes present. To the next section of type of haloalkanes. So now we are going to deal with the type of haloalkanes. So the section we are going to study is the type of haloalkanes. On the basis of number of halogen atom attached with the alkane, the haloalkanes are of three types. So haloalkanes on the basis of number of halogen attached are of three types. The first is the monohaloalkane. Next one is a dihaloalkane. And the third one is a trihaloalkane. So, first of all, the word suggests here mono means what? One. Halo means what? Halogen. So, I can say that what is alkane? sp3 hybridized carbon of alkyl group. So here, what is a monohaloalkane? When one halogen is attached to sp3 hybridized carbon atom of alkyl group is a monohaloalkane. For example, just see here we are taking one new example here. This is our 3-carbon alkane and called the propane. What is it called? Propane. So what I have done here is I have replaced one of the hydrogen atom by a halogen atom. Now it is what? Monohalopropane. It can also be considered as a normal halopropane, or I can say it as monohalopropane. Why is it so? Because here only one halogen is present. If there are two halogens present, for example, I am taking the similar case of propane here. And what I have done here is I have replaced two hydrogens by halogen. Now there are two different trends of replacing two hydrogens. For example, I have replaced one of the hydrogen by halogen here, and from here also I have replaced one of the hydrogen by halogen. So this is a dihaloalkane. Why so? Because the two hydrogens are replaced by two halogens, or I can say this alkane is having two halogen atoms, so it is considered as a dihaloalkane. Now we are coming to the next section of trihaloalkane. In case of trihaloalkane, the three hydrogens are replaced by three halogens, leading to formation of a trihaloalkane. This is propane. And what I have done here is I have replaced each hydrogen of a carbon by halogen. Here, similarly, one hydrogen is replaced from this carbon, and here also I have replaced one hydrogen by a halogen. This is a trihaloalkane. If I am coming to the general configuration of haloalkanes, so now you can see here how many carbons are present. Let's suppose we are taking another example. How many carbons are present? Here are 3 carbons. How many hydrogens are present here? 3, 4, 2, 6. And how many halogens are present here? 2 halogens. So I can take it as X2. Now, if I'm thinking about the configuration of monohaloalkanes, how many carbons are present here? 1, 2, 3. How many hydrogens are present here? 3 to 5 and to 7. And how many halogens are here? 1. So, and here also, how many carbons are here for trihaloalkanes? 3. How many hydrogens are here? 2, 3 and 5. How many halogens are here? 1, 2, 3. So if I'm reading about the configuration of monohaloalkane or simple haloalkanes, so the number of hydrogens are double plus 1 than that of carbon. Or I can say the number of hydrogens are 1 more than the doubles of carbon. This is the general configuration of monohaloalkane or the haloalkane. This is a question which is being asked by you in your worksheet as well. What is the general configuration of haloalkane? So the general configuration of haloalkanes is this, that the number of hydrogens are twice the number of carbon more than. So number of hydrogens are twice more than 1 than that of carbon. This is the general configuration of haloalkane, which can also be written as Rx. So this is all about the type of haloalkanes, monohaloalkanes, dihaloalkanes, and the trihaloalkanes. Similarly, haloalkanes are also being classified on the basis of hybridization of carbons, and there are different types of haloalkanes as well. We will deal with them also.